Hello students, welcome back to my YouTube channel Organic Chemverse. In this video, I am going to solve a question based on the structures of the alkane molecules. The question goes like this. What is the smallest alkane? That is the one with the smallest molecular weight which possesses primary, secondary and tertiary carbon atoms. In order to solve this question, you need to know how to convert the IUPAC, commonly known as UPAC nomenclatures of molecules to structures. So let's quickly write down the bond line structures of these molecules. For 2-methyl propane, the structure is this. So propane is the longest chain, hence 1, 2, 3. And at the second position, there is a methyl, so 2-methyl propane. Let's write down for 2-methyl butane. So butane, 1 carbon more. So in the principal chain, you have 4 carbons. So 2-methyl butane. Let's take option C, 2-methyl pentane. 2-methyl pentane. This is 2-methyl pentane. Let's see for option D, 3-methyl pentane. So these are the bond line structures of the molecules. So you already know what is bond line structure. That means when you represent a bond as a line, and we tend to not to write the atoms like carbon and hydrogen here, right? So now the question says that you are supposed to identify molecule with primary, secondary, tertiary and possibly the smallest molecular weight. Let's analyze each molecule. We know that a primary carbon is the one which is attached to only one carbon. So we have 1, 2, 3. In fact, 3 methyl groups. All methyl groups have primary carbon. But look at this carbon. A carbon attached to 3 carbons is tertiary carbon. It doesn't have a secondary. Therefore, A is not the right option. Let's move on to option B, that is 2-methyl butane. So we have 3 methyl group, hence it is primary, right? So we have a carbon which in turn attached to 2 carbons, right? Directly I'm talking. So therefore this is secondary. And what about here? It is attached to 3 carbon, hence it is tertiary. Same way, look at these structures, they all have similarity, that is they have primary, they have secondary and tertiary, right? Same with this, it has primary, secondary and tertiary. But the question says that it should have smallest molecular weight. So among B, C, D, the one with the less number of carbons will have smallest molecular weight. Hence, the right option is option B. Thank you for watching this video.